Okay, so the title for my presentation, Biosynthesis CS from Biomass offers many new business opportunities in Russia. We can write on, go to the next slide. I will talk about the company itself, maybe the background, how we grew from the coal gasification at Gaskombinat Schwarze Pumpe in Germany. And how we developed our own technology for biomass gasification. I will give you one insight into the process itself. So we are realizing an entrained flow gasification process for solids, for biomass. And as you know, it is very tricky to gasify a solid material into an entrained flow gasifier. We are doing this on a 5 bar pressure. And then here still you have to think, okay, what is the challenge to take the solid, to pressurize it up to 5 bar and then gasify it in a continuous process. So we do not have a batch process, we have a continuous flowing process because the later on chemical synthesis needs a continuous stream of syngas. Then I will show you the development in Germany. We have built a 45 megawatt gasification island with a Fischer-Tropsch unit. Which needs up to 10 tons of biomass an hour. And so when you are in Germany the next time near Dresden, you are all very welcome to visit, to have a look around. And then I'll give you some information about possible options of syngas. So we can go on, please, to the next slide. Yeah, so we are dealing with carbons, biocarbons from biomass, hydrogen, oxygen, and we are a renewable German company. So Korean, this is where the name comes from. We come from the former German Deutsche Brennstoffinstitut, which has a very traditional history in gasification at the Gaskombinat Schwarze Pumpe. And when we have developed, or when the company was founded after the reunification in 1990, and the German automobile industry got to know that we are dealing with maybe Fischer-Tropsch fuels, with biofuels, with biomass gasification. So the VWs, Daimlers, they contacted us and showed a very high interest on BTL fuels. So that's why we had a strategic decision to enter into the BTL market and to be the first mover who own the technology to do Fischer-Tropsch fuels. So, do you know where Freiberg is located? If you have a picture of Berlin, maybe 200 kilometers south is Dresden, and just between Chemnitz and Dresden is a very little, very neat town. 50,000 inhabitants, and it's the Silicon Valley of gasification. So Siemens is there, many gasification technology providers are there, and you all know probably the Technical University, the Bergakademie Freiberg, which is quite famous. And this town will have a 850 years history next year, so maybe you can come also to visit and share the party. Yeah, we have 800 employees. We have an office in Houston and in Beijing. So for the coal gasifier, we see a huge market in China, so that's why we have an office in Beijing. Maybe we can go to the next slide. This is pretty much the structure of the company. The 2 offices, so you have to be real near to the clients. So we have the office for the Chinese clients for coal gasification, for the markets in America, the Houston office. And we have also the Beta plant, which is the fuel production company in this group. And then we have also little components, factory shop to produce the burners and all the core equipment for our technology. The company is in private hands. Only a little share for the automobile branch, which share of maybe up to 11%. So what we are doing is we are offering engineering packages, licenses for BTX and CTX technologies. We are manufacturing, and this is maybe one difference to other companies. You can produce in your country, so this is what we say to our clients, all the things you want and you can get, we want to produce only the conveying systems and the burners, the key equipments. And as long as we have an EPC who cares about your project, we can play a very big role or just a very small role depending on the project scale. And we have also a biomass division which deals with biomass. And we can go to the next slide. I will show you some pictures. We have. You can go to this, please. Or maybe, as I said, we took the Schwarze Pumpe gasifier. We moved into a modified coal gasifier, which is our CCG gasifier. That's an entrain flow coal gasifier which operates on dry dust. And we also, it took us maybe 20 years to shape a Carbo-V process for solid biomass gasification. Now to the next slide. Yeah, for the biomass gasification process, the people will ask, so this is maybe the first question they ask, what kind of solids or what kind of biomass can you gasify? So we would like to have the category 1, which is timber, pulp and paper, industry waste, wood chips, or energy properties, sawmill residues. If you do not have 200% the category 1, you can maybe move down to the category 2, forest residues, timber, agricultural residues. We have to take care on 2 parameters within the process. We have to have an exact look on the ash content in this biomass, and we have to have a look on the ash melting behavior. So depending on those 2 parameters, we can have a mixture of biomass. On the right side, you can see just some feedstock requirements we have for our beta plant. So for the beta plant, we have 2 streams. One is waste wood, which is already dry. We do not need to dry it. The other half is from the Saxony forest. It needs to be dry within the plant, and we have a share of 50-50. The size is, I could not bring some samples, but the size is maybe a little bit bigger than, maybe as your phone, a little bit bigger than the business card, so just wood chips. And now we can go on to the next slide, please. Here you can see some pictures. So we have for processes for the development of some planting equipment for energy crops. We have some research work there, and some I guess already 300 acres of land. We planned this. One I think a couple hectares or 100 almost hectares is near Schwedt in Brandenburg. Some of it's in Poland, and we have near Freiberg some hectares. And you can see some demonstration of the planting. And now we can go on to the next slide. This is near Freiberg, some demonstration. It goes really quick. The truck is going, and it's planting really quick. Now you can see on the next pictures some results. So as soon as you prepare all your ground, so you have to invest some effort to clear ground, but then you can plant it once, and you can harvest your wood every year, 3 years for 25 years, and you will not have a problem. So you can see sort of a little tree after 3 months, after 6 months, and then after 1 year, it's a quite nice tree with a very thick bottom. It's thicker than the blackberry. Okay. Why we are doing, and now it's maybe more technical, why we are doing entrain flow gasification, and this is the answer to this question. There are fluidized bed gasifiers, there are moving bed gasifiers, but you have in different processes you have a different syngas composition, and if you want to go to chemical synthesis, the question is how rich of hydrogen and CO is your syngas. If you use fluidized bed gasification, you will have up to, and this is what you can see on this axis, you will have up to 13 or up to 15% of methane in your syngas and a low number of reactive components. If you go to entrain flow gasification, which is on a high temperature level, on a certain pressure, then you will reduce your methane content in your syngas. And if you are doing this in the entrain flow gasification process on a pressure level of 5 bar, then you can reach almost the 0 point. Which means with the high temperature, your tars are very low in the syngas. It's a very, very clean syngas with a composition up to 80% of H2 and CO, with almost none methane in this syngas. Then we can go on to the next slide. And this is maybe the main part of this presentation and the view on the process. And I will guide you through real quick so you can get most of the information. So at the very beginning we have the solids. In the first step we have a reactor which is a pyrolysis reactor. It has a reaction time of up to 20 minutes and what we want to do with this first step is to make from the solid a gas. So you will have after this process, which operates on up to 500 degrees Celsius, a pyrolysis gas, and depending on your composition of the biomass, up to 20 mass percentage of biochar. We'll then go to the next step of the high temperature gasification process. You can beautifully gasify a gas in an entering flow gasification process. We are doing this on a very high temperature level of 1700 degrees. Then the syngas goes to the quencher, and if you have a look on coal gasifier, what you use is you use a water quencher where you lose efficiency, and we use this biochar to cool down the syngas. And if you have a look on the amount of biocarbons from your biomass, 99.9% of carbons, biocarbons from your biomass go into the syngas. So this is one important thing. Due to the high temperature, the syngas is very, very clean, no tars in it, we cannot detect any tars. And then you have a very, very beautiful glass slag, which is one waste stream down here. Then you go further after the quencher, you may have little particles of ash, and of course of the biochar, which goes with the stream. And this is this one right here. After the deguster, we take everything which goes out of the quencher with the syngas. We will take all the carbons again and bypass them also to the gasifier. So it's really you will never lose of your bio-green carbons in this process, and this is a very, very nice thing. Of course, it's a heat source. We use this heat source for biomass drying in this process, and later on you can have your synthesis, whatever you want to have. So basically 3 steps. We make the solids a gas. Of course, you have biochar. We use all carbons into the biomass gasifier to use all carbons. We have high temperature, no tars, a beautifully syngas. And now we can go on to the next slide. You can see an extract of the syngas. So you will not find a process where you can achieve up to over 80% of reactive components in your syngas, and a very, very low methane content. And of course, operating on hydrogen, depending on the purity of your hydrogen, your nitrogen is then also very low. We can go to